Hey, this is Mr. J here, and let's look at an example of combination of transformations. So up to this point, we've had three different lessons where we learned about reflections, usually about a line of reflection, rotation, about a center of rotation, and translation, which moves all the points of a particular figure or point by the same amount. So let's start out by doing a reflection about the y-axis. Well, if you remember, our reflection about the y-axis means that we're going to reflect about the y-axis here, right? And so that means we're going to move horizontally. In order to move horizontally and to preserve distance, that means that the x value has to change signs, but the y value is not going to do that. So let's go ahead and apply that to our point here. So our new point A prime is going to be at -5, 3. So let's go graph that. We're going to go straight across. We're going to count 5 units. 1, 2, 3, 4, 5, and we end up right there at A prime, which is -5, 3. Okay, so that's the first transformation. This could be an example where it'd be like a rectangle or a triangle or a square or something like that, where you would move 2 or 3 more points and everything, and you'd move an entire figure. But for speed and ease, let's just use this one point. All right, so next let's rotate 270 degrees clockwise. Well, if you remember, all of our rules that we've learned, they've been learned in terms of counterclockwise. You know, our anchor chart we've got on the board, on the wall there, it's all in terms of counterclockwise. So what's the equivalent counterclockwise rotation from 270 degrees? Well, it is a 90-degree counterclockwise rotation. Well, what's that rule? If you remember, that rule for a 90-degree counterclockwise rotation means we're going to swap x and y, right? We're going to swap x and y, but we're also going to change the sign of the y value that becomes the new x value. So let's apply that to A prime and figure out what A double prime is. All right, so A double prime is going to be 3, -5, and then that right there tells me to change that sign right there. So we've now gone from -5, 3 down to -3, -5, -3, -5. So right there we are. We're at A double prime, -3, -5. And that makes sense because we move from Q2 counterclockwise 90 degrees, which takes us into Q3, right? Takes us into Q3. We move one quadrant. Actually, let's do the last one. Translate by a translation of x plus 6, y plus 4. So A triple prime, final answer is going to be -3 plus 6, substituting the -5 plus 4, we get A triple prime is equal to, what is that, 3, -1, right? 3, -1. Do a quick little check. -3 plus 6 is 3, and -5 plus 4 is -1. All right, so let's go. So 3, -1 right there. So that is A triple prime, right? So that's A triple prime. That's an example of combination of transformations that could be applied to, again, a more complex figure like an equilateral triangle or a right triangle or something like that. You would basically just do each one of these steps for each one of the vertices, and that would give you the complete set of combination transformations. Thanks.